Hello, my name is Howard Milano, and today I'm going to show you how to make a FreeCAD animation of an angular transmission, an angular power transmission. It looks like this. So there is one of the discs is a power disc, and using an angular rod it drives another disc, so it transfers power from one plane to this other plane at a 90-degree angle. And I'm showing you how to do it for one rod, and it's really simple to add two other rods to it. I won't do this in this tutorial, but I might make another tutorial for it in the future. So let's hide some things. And it's basic disk. Using the variables, so the angle we use to rotate, we have a disk diameter, which is the whole thing, the whole diameter. The disk height is the padding. The disk radius is half the diameter. Hole distance is from the hole to the center. And the holes are 120 degrees away from each other. Okay, that's the disk. Angle rod. It's the basic two lines. Use the additive pipe, rounded corner, and fillet it. And you saw the variables for it: rod arm length, this distance, and the diameter. Alright, we want to rotate one of the discs, and we're going to use Master Sketch for it. This is a basic rotation of an object. So let's go back and set angle to something visible. So we hooked the object up to the center here and align the edge there, and we vary it by angle. That makes the object rotate. Here is the local coordinate system that we're going to insert in the Master Sketch. Use the Master Sketch in the OXY. So that means the local coordinate system will rotate. And then we attach the disk to that local coordinate system. It's inserted in LCS disk 1. So when we make it visible, now the disk should rotate with the local coordinate system. Okay, basic example of how to make something rotate in the OXY plane. Alright, the other disk is a little bit different. And I made another example, another tutorial that shows how to rotate objects around the X, Y, and Z axis. So this bottom disk rotates around the Z axis, and this one rotates around the X axis. So how do you do that? I didn't use a sketch to position this. I basically created a local coordinate system, attach it to the origin, make it the mapping YZX that makes it sit over here, and I'm going to rotate it with variable angle, and I'm going to move it over in the Y and the Z. And how much do I move it over? Well, it's this much. I'll show you why it's this much. So we have these things, and when we show the rod, and we go back to the LCS disk 1, the attachment, position, here. So we move it over in that direction, a portion of the arm length plus Well, this is at the wrong angle. Let me set it back so it is easier visible. 0. Okay, now let's go back to disk 1 and position. Okay, so to move it over this way, we need a portion of the arm length over here, a quarter of the arm length, plus the whole distance over there. And it's going to be the same way going up. We're going to use part of the whole distance, and, I mean the whole distance and the rod, this part of the rod, this rod arm length. So they're both the same, exactly the same, the X and the Y and the Z. So that moves it over and up and makes it rotate. So when we hide this, you can see that the two discs rotate. Now we're going to insert the angle rod, and I didn't insert it in Master Sketch. I like to make separate sketches for separate objects. So make a rod 1 sketch, hide the disk. Here's the rod 1 sketch. It is whole distance away, and over here is where we insert the local coordinate system for the rod. And again, it's angled by angle will rotate. Here is the rod, and so it will rotate using angle. So there's the sketch. Then we have the rod, and it's inserted in that sketch that we just saw in the OXY plane. And then we add the angle rod, and we put it in the local coordinate system, and it is angled. When you add it, you have to angle it slightly. I'll show you why. So we have the angle rod, and by default angle will show like this. It will try to attach like this, but you say no, that's wrong, I have to angle it. So you angle it in the X. Alright, that angle rod is inserted now in the disk, and you can see the other disk is it lines up correctly. If it doesn't line up, you have to rotate this disk. I'll show you in the LCS disk 1. Placement, or is it in the disk? There it is. In the disk was rotated 270 degrees, so the whole lines up with the angle rod here over here. Alright, so the angle rod sits there. Now it has to, I'll show you when we rotate, it always has to point in the same direction, the angle rod. So the disc spins with angle, but this one has to point in the same direction, and it has to move up and down. So let's talk about the angle first. So the rod in the rod body, we're going to make it angle and going to vary it by angle. And you might say, well, isn't it supposed to be minus angle? You'll find out right away if it's angle or minus angle. It will turn the wrong way. And it is angle because we rotated the rod. And how do we make it go up and down? We do this in the Y here. And I made a little sketch to explain how we got to it. Okay, let's go back to variable, set it to 45. Alright, So here is the lowest position of the rod, and at 45 degrees angle it sits over here. So we want to know how much we want to move the rod up. We want to move it this portion up. It's a portion of whole distance. It's basically whole distance minus this portion, and this little portion here, we know this is angle. The cosine of angle is that over that whole distance. So this is the cosine of angle times whole distance. So this little piece is whole distance minus that piece. So it translates in the formula. It looks like this. So this whole distance, that's that whole, minus this portion is whole distance times cosine of variable angle. All right, so now let's go back to the rod. And how do we do this? So we want to change the Y position, and to change the Y position exactly with the formula that we just computed. So it goes up and down, it varies by angle, so it stays in the same direction. Everything is lined up. There you go. Angular transmission, angular power transmission using one rod. So do this, do it as homework, duplicate all this work, make it work like this, and then add the two other rods. In the future, I'll add a tutorial that shows you how to add the other two rods. Okay, hope this helps. Thanks for watching.